Alright, hello everyone and welcome to RASAYAN Academy, and my name is JAGRITI Sharma, and guys, we are also going to solve the 4-mark questions today. Okay, as I've already told you, I'm having two playlists for the 2-mark question as well as the 4-mark question. So I've already uploaded 2 videos in the 2-mark question playlist, and this is my second video on the 4-mark question series. Okay, alright, so guys, let's start the session for today. Alright, so let me also tell you that I'm also an educator on the Unacademy Plus platform, and guys, if you have not yet visited my profile, I would suggest you to do so, because there is a lot of free content which I have already created on the Unacademy platform, and they will be available in the form of special classes as well as free video courses. Alright, also let me tell you about the Plus courses. What are plus courses, guys? They are regular classes basically, जैसे कि daily classes होती है, आप daily coaching जाते हो, so they are daily classes, or let's say regular classes if not daily, and it is basically focusing on complete syllabus preparation, completing the syllabus for the CSIR exam for the June 2020 examination. Alright, and so basically we are just starting the next 6-month preparation for the CSIR exam, CSIR NET exam June 2020. So we are just going to start. I have already created a preparation strategy course. So guys, whenever if you are already plus member, then you can go and watch the strategy course. It's a very good one because I have put in a lot of time and effort for preparing the strategy for the next 6 months. I have also given you study plans that how are you going to study for the next 6 months. I have tried to give you maximum clarity कि आगे कैसे प्रिपेयर करना है. अगर आप बिगिनर हो तो भी आपको काम आएगा. अगर आपने ऑलरेडी एक स्टेट अचीव कर लिया है प्रिपरेशन में, देन ऑल्सो इट विल बी वेरी हेल्पफुल फॉर यू. ओके, along with that, I'm also having batch courses. So what is batch course, guys? There will be 3 educators who will be differently handling 3 subjects basically. So I will be taking organic chemistry, Nurul sir will be taking inorganic chemistry, SD sir will be taking physical chemistry. Okay, and we will be we'll try to complete some portion of the syllabus in the batch course, okay, and some portion of the syllabus in my individual course. तो ये जो बैच कोर्स है और जो इंडिविजुअल कोर्स मैंने आपको दिया है, आई हैव प्लान्ड इट फॉर 3 months, January to March. So I will be completing all the organic chemistry by March, and after that from April I will be taking inorganic chemistry. Okay, and also I will start in the month of May also we will be doing some practice and revision stuff like that. Also I will be taking some important topics from physical chemistry as well. Okay, so this will be my focus January to March. In the plus classes I'll be taking organic. We are also having special classes, we are also having YouTube sessions. तो वहाँ पे भी हम जो अभी तो गेट के क्वेश्चन भी काफ़ी सारे सॉल्व करने वाले हैं guys. Let me also tell you that from the month of January on my YouTube session basically, which is Unacademy YouTube channel. Okay, so I'm having live sessions on Unacademy's YouTube channel, which is Unacademy Live for CSIR NET. Okay, तो इस channel पे I'm already conducting a lot of live sessions, and in the month of January I will be completely focusing on GATE previous year questions. Okay, so I would suggest you to come up and watch it, and guys, definitely we will be completing maximum syllabus as well as solving a lot of previous year questions from all the 3 subjects. Okay, and I have already done the paper analysis, I have already done the mark analysis for every paper, physical, inorganic as well as organic. आप इस channel पे जाके वो सारा सब कुछ देख सकते हैं. Okay, alright. So if you want to take any package, because Plus is it's a paid platform, guys. So if you want to subscribe to Plus, you will have to select from one of the 1-month package, 3-month package, 6-month, 12-month as well as 24-month package. तो उसमें अगर आप कोई भी पैकेज सिलेक्ट करते हो, फॉर एग्जाम्पल 6 month, फॉर एग्जाम्पल 1 year, डिपेंडिंग ऑन योर प्रिपरेशन लेवल, ठीक है, then you can use my code JAGRITI S for a 10% discount. आपको एक एजुकेटर के कोड से 10% डिस्काउंट मिलता है, and never forget to use the code. Alright, okay guys, so I hope I'll see you in the plus very soon. Okay, so the first question for today is the major product of the following reaction is. So guys, देखो it is not, it's a very simple question that I have given you over here, and we are starting with simple questions, and then we are going to build up more and more concepts कि ये simple questions हो जाए, उसके बाद में हम mix pattern लेंगे कि एक ही question में 2-3 reaction mix हो गए हैं, something like that. Okay, so वो हम इसके बाद में cover करेंगे. Alright, so the major product of the following reaction is, so what are we given? We are given this system, and the only reagent which is given to us is our acid. So we are having acidic conditions. So what is the product? It's a very simple question, guys, and it's a direct name reaction. Okay, and this question was asked in the GATE exam only. Okay, so what you can do is just stop the video, try to think about the question, and then resume to answer. Alright guys, I hope that you have figured it out. This reaction is dienone phenol rearrangement. Dienol phenol rearrangement. Okay, I hope it clicked. Alright, so what is the dienone phenol rearrangement? Chalo, let's discuss it over in the next slide basically. Alright, so the dienol phenol rearrangement is something like this, in which we are having a dienone system. So this is our dienone. So there are two dienes, and in the middle of that we are having one. So this is our dienone system. Okay, and over here, this is our carbon connected to 1, 2, 3, 4 carbons, and this carbon is connected to 2 other carbon, 3 other carbon, and there is one hydrogen over here. Okay, so when we are having this type of a system and we have acid in the medium, definitely the acidic proton will be taken up by the lone pair of oxygen and it becomes positive. So ultimately what happens? Ultimately the pi bond is going to favor the abstraction of a proton from the acidic medium. The pi bond is going to push electron density on this oxygen, or basically it is going to stabilize the OH group. Alright, so after this has formed, what will happen? Alright guys, so the next step is rearrangement over here, as we can see. So the methyl is going to get transferred to this carbon on which a positive charge would have been formed, because the alkene bond is shifting over here like this. Okay, so I hope that you are able to understand. This is dienone phenol rearrangement, and ultimately we are getting the OH group, okay, and the rearranged alkyl group, and also we are getting a positive charge on the direct opposite carbon. Okay, so यहाँ पे हमारा अगर carbonyl group था, so we are getting the positive charge on the direct opposite. Why? Because of the rearrangement. Okay, now what we see, now we can see that we are having water in the medium as well, because there is acid, we are having water, so the exchange of proton is going to take place. So in the first step, the oxygen has taken up a proton from the acid. In the next step, what would happen? One of the proton will be lost for the re-aromatization process. This is called gaining of aromaticity back again. So this is re-aromatization over here. So the proton is lost back to the medium. Okay, so this is how proton exchange can happen, and this is how we are getting our phenol. So we started from dienone system. We started from dienone system and we ended up on phenol, and in this reaction we are also having a rearrangement step. Okay, so this is our dienone and phenol rearrangement, and ultimately the methyl group is getting transferred. So both of these methyl will be opposite to each other, as we can see, and this is our phenol ring. So let's go back and let's select from the options which are given to us. So in the first option, both the methyl are opposite. Here also both the methyl are opposite. Here methyl together, no. So C and D are completely wrong, so we can just eliminate. Now we are going to focus on A and B. So guys, see, the carbonyl group is, if we look from here, so it is there on the third carbon. It is there on the third carbon, right, from this ring junction. So how can it come on the second carbon? There is no shift in the oxygen, isn't it? There is no shifting in the position of the carbon oxygen bond, just that it is opening up from the carbonyl compound to the alcohol. So that is why we can say option A is the correct answer and B is not. Okay, I hope that you are getting the gist of the question. It's a very simple question. I hope you will be able to do it by yourself. Okay, so let's see question number 2, guys. So in the question number 2, the stereochemical notation for the following molecule are. Okay, so we are having two systems over here in the same molecule. If I have written the oxygen like this below the plane basically, alright, which means that there is hydrogen above the plane, and guys, hydrogen is our least priority group, isn't it? Yes. Okay, along with that we are also having an alkene system. Okay, so let's see what's the question, what are the options. So in the options we see, in option number A we are having 2Z4R, we are having 2Z4S, then we are having 2E4R and 2E4S. Try to stop the video and try to do it by yourself, guys. It's a very good question and a very easy one at that. Okay, so the first priority is given to carboxylic group, definitely in the nomenclature. Okay, and then the last is given to our hydroxy. So if we start from over here, 1, 2, 3 and 4. So that is why the stereochemical descriptor on carbon number 2 as well as on carbon number 4 is asked. Basically for the alkene system, is it a Z alkene or is it a E alkene? Okay, and ultimately what is the stereochemical descriptor on the 4th carbon. Chalo, to R and S, so I have already told you how to find out, how to give the priority. Okay, alright, so let's give the priority. The first priority goes to oxygen, it is having the greatest mass. Then the second priority is we have to select between these two carbons, isn't it? So this carbon is connected to 2 real carbons and 1 hydrogen. This carbon is connected to 1 real carbon, 1 phantom carbon and 1 hydrogen. So definitely second priority goes to this because it is connected to 2 real carbons. Third priority goes over here. So this is 1, 2, 3 anti-clockwise. Alright, and okay, so when the molecule is already there in the flying wedge projection and we are finding it out in the flying wedge projection, we see the direction only. Okay, so over here the direction is anti-clockwise. So anti-clockwise rotation gives us S. Now there is one thing that we have to see, that the least priority group is above the plane. But to find out the R and S descriptor in the flying wedge projection, we have to keep the least priority group below the plane, or let's say farthest from us. Okay, so but over here it is above the plane, so we are just going to invert it to R. Okay, because from the anti-clockwise rotation we are getting S, but because the hydrogen is least priority group, we are just going to invert it to R. So ultimately we are getting 4R. Okay, alright, then let's go to the to the alkene system. Okay, so let's go to the alkene system. Let me erase it a little bit. Okay, so who is having greater priority, that we have to decide in the case of alkene as well. So the first priority definitely goes to the carboxylic acid group. Secondly, over here this second priority goes to our methyl group. On the other side, on the other carbon, first priority goes to this carbon and second priority goes to hydrogen. Okay, so as we can see, it is E alkene. Both of them are, 1 are opposite, 2 are opposite, right? It is our E alkene. So it is basically 2E and 4R. Okay, so this is the configuration 2E4R. I hope that you try to find this out by yourself. Okay. Also, we are having question number 3. Now guys, it's a very good question. The product of the following reaction is, so what is the product of the following reaction? So if you have already studied pericyclic reaction, photochemical reaction, you would be able to solve it by yourself as well. Alright, so in this reaction we are having, so again the product of the following reaction is, so basically it's a pericyclic, very simple reaction. Okay, and if you are accustomed to looking at this system like this, because the system is always drawn already in the perfect position for a ene reaction. I hope that you have heard about ene reaction. It is always there in the perfect position. So what is going to happen ultimately? The hydrogen comes over here, there will be a bond formed over here basically from this carbon. because the hydrogen is getting attached to this carbon, so this carbon is going to attach over here. Ultimately pi bonds comes over here. Okay, so ultimately we are going to get a 5-membered ring which is formed. So in all of the options we are getting the 5-membered ring. This is definitely wrong. Getting 6-membered ring, not going to happen. And after the 5-membered ring there will be no 4-membered ring, so C is also incorrect. What about option number A and option number B? That we have to see. Okay, so definitely guys, if one of the alkene system, let's say this alkene stays below the plane, then definitely what we are going to get, definitely the stereochemistry is going to be same for both these groups. Okay, so let me see, I think I have drawn it already. Yeah, so in a much neat and clean manner I have already drawn this. This is our ene reaction basically. So it's similar to a Diels-Alder 4+2 cycloaddition, but it is not a cycloaddition just like Diels-Alder. Okay, this is our ene reaction in which there is a sigma bond which is involved. So in the Diels-Alder reaction, 4 pi electrons from the diene and 2 pi electrons from the dienophile. Over here it is 2 pi electrons and 2 sigma electrons plus 2 pi electrons. So yes guys, this is also asked right in the exam. What is the reaction species, or basically what are the electrons involved in the ene reaction as well as Diels-Alder. So in the Diels-Alder we know it's 4+2. In the ene reaction it is 2 pi, 2 sigma and 2 pi, right, something like this. Okay, so this is how the reaction is going to proceed. Just as I have told you, the pi bond, it's a concerted process and hydrogen is donated to this carbon like this. Okay, so this is our product. Similarly, coming to the compound which is given in question, I have already shown you the steps and it is going to be an intermediate, something like this. Okay, so what I have just shown you is, this is our intramolecular ene reaction basically, and that is why we are getting this 5-membered ring over here. Okay, that is why we are getting this 5-membered ring over here. So whenever you are in a doubt, always try to draw the transition state, क्योंकि उससे पता चल जाएगा कि कहाँ bond form हो रहा है. Okay. Alright, and this is our final product. The hydrogen which was over here has transferred to this carbon and it has ultimately formed a CH3 group, and this carbon becomes sp2 and forms the alkene system. Okay, so the stereochemistry is going to be on the same side like this, and our correct answer is option number A. Alright guys, I hope that you are clear with this question and I hope that you tried this out by yourself as well. Okay, so one more good question. Question number 4 is, what is the product of the following reaction? So what is the product of the following reaction? It's a very good question guys. Try to do this by yourself. So ultimately we are having toluene and we are having the anhydride, and in the presence of AlCl3, excess AlCl3, what is the product being formed? Okay. So we are given 4 options when the toluene is reacting with succinic anhydride in the presence of Lewis acid, that also excess. So what will be the product that is formed? We are having 4 options. Either it is going to form a 6-membered dienone system, or it is going to attach only on one, only one electrophilic substitution is taking place here, 2 electrophilic substitution is taking place here. The B and C are similar, just that the carbonyl over here is hydrolyzed basically to carboxylic acid. Then which of the following is correct? Basically, is the succinic anhydride giving electrophilic substitution on the twice on the same ring or twice on different toluene rings, or it is getting hydrolyzed to carboxylic acid? Okay, so or this product is formed in which the methyl, the toluene is reacting from the ortho position basically. Okay, so A and D are showing para and ortho substitution. Okay, so this is something we are having 4 options. Try to do this by yourself. Okay, let's discuss it very quickly. Alright guys, so let me just tell you that when we are having any anhydride, over here we are having succinic anhydride. So in the presence of Lewis acid, the ring is going to open up, alright, because it is attracting oxygen. So ring is going to open up and it is going to generate an electrophile. How is the electrophile generated? Just like this. So the carbon is going to have a positive charge. Okay, so over here the lone pairs are just helping out for the bond to leave. Okay, so the carbon is it is the electrophile over here, which will be attacked by a toluene from the para position. If let's say from the para position, then what would happen? It attacked over here, alright, the oxygen gets the electron density back, alright. Now what happens? See guys, this part of the it is sorted because we know that it is going to lose a proton and gain aromaticity. So this was our electrophilic substitution. But what happens with the rest of the molecule? What happens with this part? And will it take part into electrophilic substitution? Again, let's see. So with this part, what is going to happen is ultimately, see, because the methyl is not having a very great electron donating effect plus R effect, it is not happening. Okay, and also in the whenever we are having proton exchange or whenever we are doing aqueous workup, this will be directly giving us the carboxylic acid. Okay, because we are having two oxygens over here, and it's the probability is very, very less that it is the electrophilic substitution will take place from the carboxylic acid group. So most of the times it is only taking place if we are generating acyl cation basically. Okay, so this is Friedel-Crafts acylation. So the acylation is taking place from the acyl cation, but over here it is not the acyl cation. Okay, and then ultimately we can say that it is not going to take place from the remainder of the reagent of the succinic anhydride. So only one electrophilic substitution is possible, and that also we are getting carboxylic acid at the end. Okay, so our answer is going to be option number C. A is incorrect, no 2 possible. Here also there are 2 on different 2 electrophilic substitutions on different molecules, which is also not possible. Okay, so what can we have? Yeah, alright guys, so this is the end of the video, and I'll be bringing more questions definitely in the upcoming videos, and I think that the questions which I have taken up are going to help you, or maybe if you have done them already, we are coming up with much more tougher questions. Okay, and guys, please watch the Unacademy live channel, because I have already making daily, or let's say almost daily, I'm making some getting live on it, CSIR NET. Okay, and I have done a lot of paper analysis for you to see and understand before we start the preparation. So visit this channel, visit my playlist as soon as possible. Also guys, if you like this video, please give it a thumbs up, please share it with your friends, also subscribe to the channel, and also give your suggestions that what are the type of questions that you want me to solve. Definitely I'll try to take them up. And also guys, follow me on the Unacademy for much more content. Okay, thank you so much for watching. I'll come up with next video very, very soon. Thank you guys.